Hello, I'm Matthias Cruza, and this is my demonstration video for Sprint 1. So what I have is a Raspberry Pi, acting as the main computer of the ROV, and it has a Node.js server running on it that transmits camera directly from the USB camera and controls these servos that will act as yaw, and they will also simulate the throttle control, as ESCs are the same protocol. And so this Raspberry Pi is connected by Ethernet to a media converter to Ethernet to fiber optic. It goes through a 20-meter long fiber optic cable. This is the tether of the ROV, so data will be transferred over this line. And this is great because fiber optic can do up to 100-kilometer distance, whereas regular wires can maybe do 100, 200. So this fiber optic goes to another media converter that converts it back into Ethernet and then to my computer. And my computer, I just have a standard gamepad hooked up. So if I go and I SSH into my Raspberry Pi, it's now connected over the network. I'm just gonna type my password in. We are back and I am now SSH'd into the Pi. So the network connection is just over this optical link. So there's no connection to the internet, to the Raspberry Pi, unless I share it from my computer over this link as well. And so everything on the right side of the tether is gonna be on the surface. So the last little bit of the tether, fiber optic media converter, and my computer on the surface to control the device, and then everything on this side, media converter, Pi, camera, servos, all in the ROV in the depths. And so, yeah, now that I'm SSH'd in, I can just run my startup command, and that will start up my camera server, and then my Node.js server will also start up as well. And then so now if I change over to my browser and my screen's a little dirty, I refresh, that's me. So the latency is not too bad. Let me see if I can make a clap noise or something so you can see in the camera. And so then I have this gamepad hooked up in that gets JavaScript input. So if I move this stick around, you can see the pitch controls work, the yaw controls work, and throttle on this side. So throttle, yaw, and pitch. And then so I also added in sensitivity controls. So from the controller, I can increase or decrease the sensitivity of the yaw, the pitch, as well as the throttle. I also have the lights on a toggle, which is the top bumper. I have the sample collection button here, and I have the screenshot button right here. And so this does connect to the backend. The backend does fully work. Sorry, I'm just on my kitchen floor here. And so when I give it throttle up input, you can see these servos will pitch up. These are pretty heavy duty servos, so they are a little slow. This is not a issue with the network. If I had smaller servos, they'd be basically instant. But this demonstrates the way the differential thrust will work to steer the robot, because if I have the throttle up, they're both equal. And as I change the yaw, they will be out of equilibrium, causing more thrust on one side and to steer the robot. And the pitch also works, but I don't have a third servo right now. And that is the whole system. And you can also see through the terminal, these are all the commands that were sent over. And I'm quite happy with them, quite satisfied with what I have so far.